Welcome to this webinar. You are watching a recording to introduce you to the Baltic Denture System. In the first section of this webinar, we want to address the question, what is the Baltic Denture System? MERS Dental developed a system for which they started 10 years ago by thinking about how they can enter the digital dental world and connect it with their existing products. Can a standard for complete dentures be defined? MERS Dental is known in the information and dissemination of the philosophy for model analysis and teeth setup according to Professor Dr. Albrecht Gerber. To define a standard, MERS Dental analyzed hundreds of toothless jaws. Only-dentulous jaws remain areas that are not subject to atrophy, can be found and marked. For example, the papilla incisiva, the area of the tuberosities, the pterygomandibular fold, and the area of the retromolar pads. By measuring the distance between these points, you get a data grid. The results showed average sizes for toothless jaws. MERS Dental defined pattern with teeth from the portfolio, in optimized function and digitized these constellations. They are implemented in a new form of milling blanks. The BD load. The rows of teeth are already polymerized into this. The BD load is a new kind of a milling blank with integrated teeth setups. The denture is still integrated. Everything will be designed around the teeth and shaped by the milling process. BD load milling blanks are pre-foamed setups in several sizes. S for small, M for medium, and L for large. And with a setup either to the first or second molar for alignment according to the patient-specific alveolar ridge situation. Within the basic sizes S, M, L, there are different tooth arch shapes divided into M for medium, a normal arc shape; N for narrow to U-shaped and more closed arc shape; W for wide, a V-shaped and more opened arc shape. Therefore, there are 13 pre-formed tooth setups in all common shades available. The BD load is packed with many features. Fixed and polymerized installation of the teeth. Residual monomer content below 1%. 3-layer posterior teeth. Setup 6 to 6 or 7 to 7 available. Only one milling process per jaw is required. No milling of tooth pockets, no sticking or gluing of the teeth. Highly cross-linked material. 4-layer anterior teeth. The occlusion concept is based on a setup philosophy according to Professor Dr. Gerber, Switzerland. It is a canine guide occlusion concept with unilateral support. In addition, the tooth-to-tooth relationship establishes the autonomous mastication stability. Characteristic abrasion facets and low cusp inclination are specially designed for lingualized setup. The anatomical chewing surfaces of the posterior teeth centralize the chewing force to the jaw and avoid horizontal thrusts. The mortar pestle principle leads the teeth into a unique centric, with high mastication efficiency. Let's go back to the question. What is the Baltic Denture System? The Baltic Denture System thus offers a balanced system if you want to implement the requirements for efficiency, quality and economy in a system for the production of digitally created, removable dentures. How can you get into this system? There are some limitations of the system. Due to the rows of teeth firmly fixed in the BD load, individual adjustment of the individual teeth is not possible. Only the entire setup can be moved in three-dimensional space. The setups offer an ideal solution for angle class 1 situations. A distal shift of the lower jaw can still be solved within limits. A forward displacement of the lower jaw and angle class 3 cannot be resolved. Also, a crossbite situation can't be served. The previous process for manufacturing full dentures required many work steps and visits from the patient. The main tasks of modern processes are to have a safer process, with more precision and more efficiency. Let's start looking at how we collect the data. There are several ways to get into the system. The first option is to create all documents as before, scan the model situation set in an articulator and to import the data into the BD Creator Plus software. The second possibility is the relining of already worn dentures and the jaw situation, as well as scanning the dentures that are fixed to one another. The third version is the use of a set of templates specially tailored to the system, the BD key. The design takes place in the system's own software, the BD Creator Plus. This software is specially designed for the Baltic Denture System. It is an open software. STL data can be imported and all constructions are output as STL data. BD key are copies of the digitally available setups and the physically existing BD load. The BD key set contains tools for positioning the templates in the patient's mouth. Functional movements, centricity and aesthetic of the teeth setup can be checked in the first session. The BD key are available in PEEK and PMMA material. See detailed guidance video for further information on the MERS Dental YouTube channel. How can we get into the system? As already mentioned, it is possible to scan models or impressions of edentulous jaws in order to work with the data in the software. Every dental desktop scanner or intraoral scanning system, which can also be used outside of the mouth to scan objects, is sufficient for this. Let's see how to handle scan data from edentulous jaw models. Using a scanner with the articulator scan option makes it easy to start designing. The scan software saves the scan data of the models in the orientation specified in the articulator. But it is no longer necessary to place the models in an articulator before scanning. In addition to the scan of the upper and lower jaw model, it is sufficient to scan the models together with the bite registration. It is possible to align the data in the BD Creator Plus software. An assistant function guides you through the registration of the data records. This can be done with models and impressions. Let's see what can be designed. The software update includes some features that allows to remaster the analog workflows with the now given digital possibilities. The digital workflow starts with the planning and designing of digitally created work preparation aids, such as functional trays and bite registrations. Collecting information for the design of dentures is very important for the success of the further workflow. See some video sequences showing the new additional features. It's so easy to design a functional tray. Mark the alveolar ridge. Define the edge of the base. As an option, the base can be created with an offset. Positioning of the tray handle. Adding material, reducing or smoothing the surface and creating flow channels for impression materials is possible. An engraving option for customer numbers, date or names is given. The software can provide an initial suggestion for the occlusal plane. The wizard, top right, guides you through the process. The alignment can be checked and adjusted in all directions for each jaw individually in relation to the plane. A selection of prepared geometries as various bite wall surfaces like smooth, Rentabond, and with Artex handle is available. The design of pinpoint registrations is also possible. Coordinated sets of metal instruments for registration are implemented in a library. How to create a full upper and lower denture. The application of a model analysis provides the security for a stable alignment to the structure of the jaws. The areas are defined similar to the analog procedure, but on a virtual model. The distance between the papilla incisiva and the labial surface of the upper centrals can be adapted. If related data through the using of BD key, bite blocks, or an existing prosthesis are available. The model analysis according to Professor Dr. Gerber transfers the philosophy of lingualized occlusion without buccal contacts. This improves the chewing stability. The pin defines the path of insertion from the current perspective. With the possibility to tilt the model, a path of insertion can be chosen. The remaining undercuts are detectable and should be blocked out. The border of the denture base is represented by a line with multiple points on the virtual model. The palatal seal area can be edited. The intensity of the desired effect can be adjusted. After the denture bases have been generated, a pre-selected teeth setup is now inserted between the bases. The drop-down menu lists the virtual teeth setups according to the best fit criteria. Any other setup can also be chosen from the Teeth Master library. The setup can be moved and rotated in the entire three-dimensional space between the jaws. The position of the individual teeth can't be changed. After the selection and positioning, the denture bases will be generated. The palate fold tool projects a copy of the palatal tissues onto the surface of the maxillary denture. The field for this application can be defined for this purpose. With freeform tools, the surface of the base can be edited. Material can be added, removed, and smoothed. After a few minutes, a full upper and lower denture is created. Let's see how to design single arch dentures. Let's start importing the data. For the case shown here, 3 scan data sets were created. The upper jaw was scanned after the existing and worn denture had been relined. The lower jaw is available as a plaster model and has been scanned. The existing denture was used as a bite registration. A scan in the fixed state of the upper denture and lower model results in the third scan, the vestibular scan. The scan software was able to align the scan data with one another. If this is not possible with the scanning software, the data records can still be registered with the BD Creator Plus in a later work step. After importing the scan data, important adjustments can now be made. First, check whether the data is aligned correctly. If the upper jaw is not an impression, the orientation model can be selected. The specification of the opposing jaw is already defined when the project is set up, but can be changed in the drop-down menu shown. If the objects have already been aligned to each other by the scan software, the registration in the following step can be omitted. Make sure that the checkbox is marked accordingly. It is still possible to import an all-in-one scan. During this scan, the upper jaw and lower jaw impressions were scanned and fixed to one another in the bite position. If BD keys have been used for this, the size used can be specified in the drop-down menu. In the next step, the data must be trimmed in order to obtain the necessary freedom to design the denture base. The software automatically suggests a border. This can be edited by moving the points on the boundary line. A boundary line can also be created from the viewing direction. The gold-colored area is retained when cutting. The gray area will be removed. The plus and minus buttons offer a very helpful function. These functions can be used to enlarge or reduce the entire selected area. For a quick and easy correction of the scanned data is an editing integrated function available. This tool can be started directly from the desktop. With this function, irregularities in the surface can be cut out and evened out with a hole closing function. This function can be started in any construction phase. The following work step defines an alignment plane for the subsequent placement of the row of teeth. This level is predefined by setting 3 points. The wizard on the right-hand side of the work area specifies the correct arrangement of the points. The alignment plane can be corrected if necessary. For a better overview, the vestibular scan can be hidden using the display function. In the work area on the right, the plane can be moved and rotated in all directions and axes. A model analysis is also necessary for single arch dentures, in order to place the row of teeth according to static criteria. The settings for digital spacer and the undercut control can be set in the control field digital spacer and undercut setup. The settings for the smallest milling diameter can be adjusted. The result can be checked in the control field. You can change all settings at any time and see the result in the corresponding fields. The visual inspection of the hollowing functions and the post-palatal seal area have been improved. After the denture base has been generated, one of the tooth setups can be selected and adapted to the occlusion. A fully adjustable virtual articulator is now integrated in the software. All adjustment options are possible. The inclination of the individual front tooth guide plate is preset to a value of 35 degrees. The lateral anterior guide wings are each set to 15 degrees. The set values can be simulated using the corresponding slide controls assigned to the movement. In a further menu step, the occlusal collision can be viewed. In the basic version of the software, a static adaptation of the collisions to the surface of the teeth is possible. In order to be able to make a dynamic adjustment, a separate license is available to activate this function. By overlaying the vestibular scan, the newly designed proposal can be compared to the original data. The collisions are harmoniously adapted to the occlusal surfaces. Depending on the available CAM software, appropriate output options can be selected for the design data. After the design, it is possible to verify the result before milling the denture out of a BD load. The constructions can be printed as a monoblock denture or milled from a tooth-shaded load, the BD load TS. Special holders for the system must be obtained from your milling machine manufacturer for processing the BD load in a milling machine. The BD load have a larger diameter than normal discs for dental use. This is necessary so that large denture bases can also be milled out. Finishing dentures from the BD load is very easy and fast. So the Baltic Denture System fulfills the principle of efficiency with high quality. You can save more than 4 hours of manual work. Save time, not quality. Get your demo version and start your way into the digital supported manufacturing of removable dentures. The open system enables a flexible entry into the digital workflow. Support your work preparation with various tools designed in one software. A software especially developed and adapted to the requirements for a proven workflow to create and manufacture removable dentures. Thank you for watching this video. See more videos and find detailed information on the Baltic Denture System website.